So today we are going to have a little video about putting quadratic functions into vertex form. What does Miss Ju mean by vertex form? Well, what I mean is a form that looks something like this. Y equals something times x minus h squared plus k. And the variable used here is often a, or that's actually a constant. Now here's the overall idea. If a is more than 0, this quantity is always positive. The lowest this quantity can go is 0, so the lowest y value is k. Y will always be greater than or equal to k. So that's our vertex because our lowest y value happens at the vertex. In order to get k, we said that this quantity had to be 0. To make that quantity 0, I'm going to make this x value equal to h. And so that's what I mean by vertex form. You can really see the vertex in the form. In order to get things in this form, we're going to use a technique that we've learned in class and that I'm going to go over in this video. So here we have y equals 3x squared minus 18x minus 11. I'm going to go ahead and factor out my 3. And I have x squared minus 6x. But I'm going to make my parentheses kind of big because I know in a minute I'm going to add something. Now I want us to pause and really take note of the fact that the second line that I wrote is exactly equivalent to the first line. 3 times x squared is 3x squared. 3 times 6x is 18x. And we have our plus 11. So then I'm going to write what I would call our goal line. Our goal is to have 3 times the perfect square and then plus something out here. That's our goal. Well, we know that if we're going to have something that's a perfect square that's equivalent, we need an x here because the first term here is always this term squared. Now the curious thing is what goes here. Well, we also know that the middle term is twice the product of these two things. And so I say to myself, 6x is twice as big as 3x. So 3x must be the product of these two things. So I'll put a 3 here, and I'll make it negative because this is negative 6x. So now I really want to respect the fact that I want these two lines to be equal. They're not currently equal because x minus 3 squared is not just x squared minus 6x. X minus 3 squared is actually x squared minus 6x plus 9. So now what's in this place is equivalent to that. But I can't randomly just add 9. And in fact, I've added 27. To compensate for adding 27, I'm going to subtract 27. So now what goes here is this combination. What is 11 minus 27? 11 minus 27 is negative 16. So I'm done with what I said I was going to show you how to do. I was going to show you how to start with something that looks like this and put it into vertex form. But I'd like to end with saying, well, what is the vertex here? Well, the lowest this can ever go is 0. So the lowest the whole thing will ever be is negative 16. I'll get negative 16 when I make x equal to 3. So that's my vertex. This 3 tells me that the growth rate of this parabola is pretty steep. It's going to grow 3 times as fast as our usual parabolas. Now I'm going to do a couple more just so you get the idea. Here I have y equals negative 2x squared plus 10x minus 5. I begin by factoring out the negative 2. I have x squared, and then I think negative 2 times what would give me this? Oh, minus 5x. Then I write my goal. My goal is to have negative 2 times a perfect squared. This needs to be an x, and this number needs to make it so twice the product of that will equal this. So I split 5 in half, and I get 5 halves. And that number needs to be my 5 halves squared. Now I haven't added 25 fourths. I've actually subtracted 50 fourths. So to compensate for that, I'm going to add 50 fourths. Because if I subtract 50 fourths and add 50 fourths, I'm really in the end adding nothing. Now 55 fourths is the same as 25 halves. Negative 5 is the same as negative 10 halves. So negative 10 halves plus 25 halves gives me 15 halves. So now I want to think a little bit more about this parabola. I know that this doesn't have a lowest value because this value is actually always negative now because of this negative sign. So instead it has a highest value. This will never go higher than 0 because it will never be positive. A perfect square times a negative is always negative. So its highest value is 0. So the highest the whole thing can go is 15 halves. And we'll get 15 halves when we make this quantity 0, which means x has to be 5 halves. And also one thing to note is the vertex, 5 halves would be somewhere over here, 15 halves. It's above the x-axis, and it opens down. So no matter what, we will have some x-intercepts if we wanted to find them. Okay, one more example. Here, I picked this one because factoring out a 1/2 has been kind of a hard thing for a lot of students. So instead of y, I have f of x, but that is also representing my y coordinate. I take out my 1/2, x squared. I'm going to have a minus because I know I want this to be minus. 1/2 times what would equal 5x? 1/2 times 10x. 1/2 of 10x equals 5x. So I'm feeling comfortable that my line in blue is equivalent to the line that I started with. Now I'm going to write my goal line. My goal is to have 1/2 times a perfect square. And so I know that I need to cut that in half. Now with the minus 5, think for a moment about what goes there. If you got 25, you're in good shape. I've added 25 halves, so now I want to subtract 25 halves. Now here, this 9 is really 18 halves. 18 halves minus 25 halves is negative 7 halves. So now to find the vertex, I say, well, this is always positive, so the lowest it can go is 0. So the lowest the whole thing can go is negative 7 halves, and we get that by making this quantity 0. That happens when x is 5. Now, incidentally, this vertex is below the x-axis, and this parabola opens up, which means it also has x-intercepts. That's it for today on our video about how to put quadratic functions into vertex form.